Hello guys, how are you doing? Can you hear me?
Hey, Breno. Doing good. How are you?
Pretty good, cool. Good to see you again. All right, let's go. Share my screen. So, some of you already know me. I see some familiar faces, but just as a quick intro for those of you who don't know me yet, I'm Breno Azevedo. Wait, I have the wrong slide. Oh man, not great. Hold on a little bit. Let me get the right one. This has been pretty hectic. Actually, my onboarding week, my new job literally took me, I don't know, 80% of my life at least. Yeah, that's pretty crazy. Let me get this one. Mm. Yeah, that one. Okay, so what have I done? I'm a modeler and 3D animator since 96. Believe it or not, there were some 3D programs back then. Imagine 3D and Lightwave 3D. I was beta tester for Lightwave actually. I worked as the Electronic Arts Los Angeles contractor since 2006 up to 2010 when the studio was unfortunately shut down because Command and Conquer 4 was a big flop. Not my fault. I worked on Lord of the Rings, Battle for Middle-earth 2, also Command and Conquer 3 and 4, both during pre-production and post-production and patches related work. Yeah, a couple of screenshots from those projects. Still actively played titles even after all those years. And yeah, those were the heydays for RTSs. I think the only big RTS after that was StarCraft 2, really. So yeah, I was also producer of a massive multiplayer online space game called Taikadam and developed multiple packages for the asset store, Unity asset store. I got number 7 top seller with Rage Tools, which was the first one to bring in Vector's SVG art into the software. And I've been producer, senior developer of more than 20 games for Apple Developer Academy and Apple US sponsored and tightly supervised course, which was pioneered in Brazil and later um, inserted in Italy and other countries, Asia as well. I've been a professor for DCPR, Digital Games Graduation course, a top tier digital games course here in Brazil, where I lectured both digital arts, animation, and game development. And I got a master's from the same university in computer vision. Okay. More recently, I've been a founder of, city manager of First Foundry, a multinational studio here in Brazil. And I work in pre-production for Beyond Games and Laguna Games with many interesting games. One of them was Crypto Unicorns, pretty interesting Unity game. I'm currently the lead developer of the Total Atomic Power real-time strategy game, and I also took a position as the game development team lead for one of the products, which due to NDA I cannot disclose, from Plan A Technologies, USA. Okay, so let's get to the point at hand. We're going to talk today about communication patterns for Unreal Engine projects, right? So I think the catchphrase is realignment by itself. So basically, the goal is to show you guys a couple strategies so that you can move away and beyond from cast and how, using techniques like interfaces, C++ subsystems, delegates, or event dispatchers if you do the blueprints, and other AAA oriented workflows. So, what problem do you want to solve? The casting how? Um, uh, every tutorial which basically tries to teach you guys the easiest way to do something. Basically, you get a reference to an object. You don't know what object is that, what the type of that object, and what do you do? You cast it, right? You cast it into something. Casting basically means convert the data into another data type or data structure format. And of course, not always you can make a cast work. Yeah, you can use AI Companion if you prefer. No problem for me. It take notes and such. Although, just for the record, the session is being recorded to the cloud and will be made available to everyone who's subscribed to it. Okay. All right. So, and that creates what we call hard references. Hard references are bad. It's there's no easier way to put that. Whenever you do a cast into an object and you store a variable, if it's transient, it's a bit better. Transient means that it's like a temporary variable. But whenever you convert something like, yeah, my player just hit the door and I want to check if the door, what's the lock type for the door. And then I'm going to check if my player has the right key for that door. So what do you do? Well, um, you check for the overlap event, all good, in Blueprint, C++, whatever. And then the first knee-jerk reaction will be to cast it into whatever door type you have. Maybe, I don't know, dungeon door, whatever door class that you type that you created. And then you're going to check if it's locked, the state. Then you're going to check what type of key unlocks it, right? Because all of that data is not part of players, part of door. And how do you get that information? Okay, so the problem, well, there are many problems with that. One, of course, is that if you change the class or the definitions for variables, the naming of the variables, whatever, in the door blueprint or C++ class, automatically you create an error because now in the code for player, which is checking what's the type of the door, what's, the lock type, whatever, it's basically will be reaching out to variables or functions which are no longer there or have been renamed. That's one of the key problems. The second, which is even more obnoxious, is that you're copying the entire structure of door into player just to be able to access that data. And I have the project, one of the projects that we worked in our course here, and I'll be able to show you guys in practice. So don't worry, it won't be pure slides. Um, yeah, we have been working with this project for both. And let me make it look pretty for a second, although it gets slow because I'm both recording, sending to the cloud, and yeah, it's not light on my machine, which is not a funny machine, but that's a bit too much to for any machine really. Cincy Renegade. I like Cincy Renegade actually. Good comment, Brad. You brought that to my mind. I never worked on that on before now. Like that was for my day and time. Although I did meet the um the creative, the creative director behind it, Lou, very very nice guy. I got a signature from him in one of the games, Tiberian Sun, original box, played it, very cool. Yeah, so and that's why I'm switching to unlit, so it's not super sluggish. You guys can get some more a better reaction here. So um, let's try checking, for instance. I'm pretty sure we started with casting, and that'll make it easier to understand. Let me get, for instance, the blueprint class for the main character, which is Belmont. And let's see what we can do here. Let's check reference viewer, right? So reference viewer, which is, as you guys saw, is just select the blueprint class and right click, select reference viewer, pretty simple. It's going to show you everything that's being referenced by, you can dock here if you prefer. Let me get rid of this message. And I just right mouse button scrolling, wheel to zoom, etc., etc. So that's VP Belmont. It's a blueprint, right? but there are many things which are used in its reference, and there are many things which are being used by it. So basically, it's consuming that, and it's being consumed by all of that, right? And those are hard reference. Notice the, pretty solid white line there. It basically means that this guy has a copy of all of those guys, which is obviously not ideal. When you're lecturing, obviously, many times, some of those are not bad, by the way. This animation blueprint being referenced by BP Belmont, it's it's just the way it is, and it's like super optimized. Um, AI controller, usually. AI controllers are pretty lightweight as well, but some of those can be like even abilities. That's for the game ability system. Those are pretty lightweight and they're optimized. But having access to the game mode, that's not ideal. Okay, and actually there are two references here, which means I created a new one, I duplicated them, and somehow I didn't get rid of one of the reference, so that was surely a mistake. But even referencing just one game mode, what's game mode? It's like um, the root of whatever is running your game. Okay, basically it's something like um, how can I put that? It's the lowest level of logic that's running and which makes it sustains the game. So whenever you want to have global variables and global references, it's usually a good place to put that. I know many tutorials people go and say, yeah, go to, use the drop down for blueprint, select open level blueprint, and yay, now you got the blueprint for the level, and then you can add variables which will be seen and accessible by everything here. And this is a great place for you to put your global variables. I beg to differ. Like, what if you load another scene? You will another level, will you lose access to all of those variables? Doesn't seem wise to me. Okay, in some cases, suppose your game has only one stage. I can't imagine that happened for real, but maybe it's just a prototype. But even if it's a prototype, if you want to grow it up later, you better think twice, right? Instead of doing this straight away. So I don't recommend usually using a level blueprint to store variables. It's easy to access, yeah, but kind of flimsy, if you ask me. So yeah, creating your own game mode. And how do you select that? Basically you go to all settings and you assign that. Okay, or you can go to project settings and you select the maps and modes option, and then you have the game mode, and that's the one really used by the game. Okay, which you just inherit from game mode when you create a new blueprint class. Pretty simple. And really what it's got is basically references to all those classes. Just a second, let me get my zoom in tool so I can zoom in and make sure you guys are seeing what I'm talking about. Right, so basically got a reference to the default pawn class, which is the one which will be spawned from start position. The HUD class, which is super important. Well, I find it really useful, but most people don't use it. We're going to be talking about it in a second. The player controller class, the game state. And game state is something that's even lower in terms of access. Like it's the lowest. Like I mentioned, game mode, which is the lowest for the game mode that you're playing. What's the game mode? Suppose you're playing King of the Hill. That's game mode. And now you're playing Deathmatch multiplayer. That's another game mode. And then you're playing cooperative multiplayer, mission, single player, whatever. Those are game modes, right? And games commonly have multiple game modes. All of those game modes they run on top of the game state class. So game state is really low level, but I don't recommend game state usually for most things except for message communication. For variable storage, they have some pretty harsh limitations, right? So I wouldn't count on that for kind of like a game manager class like you would do in Unity or other engines. I prefer game mode for that. And if you think about it, there's no real reason for you to share variables from one game mode to another, right? Because the gameplay will be totally different. If not, why do you have multiple game modes? Okay, so it doesn't. makes sense that you want to share variables across game modes. But, raw data which you bring from the cloud, things like that, usually you will bring to the game state class because that's what actually shared by I don't know, maybe the theming. No, now it's a Halloween pack, and you can just do that from game state, and that'll be available. All that data which was updated there will be available to all game modes. Okay, so yeah, that was just a parenthesis because I think it's important. It also has to do with communication. But basically, I was showing you guys, and I opened this parenthesis that it's easy for you to from reference viewer for you to have too many references. Okay. The right side is not super important because basically it's, you don't know if HUD has too many references unless you go and check its own references. But this is what's being copied. The data of it's being copied into your BP Belmont class. So if I instead select size map, you will better understand what's it about. You got the size of everything that's running here in both blueprints, and sometimes it's very hard to read everything, but you have all the space taken by the post search database, which is massive because this character is using motion matching for smooth animation. Takes a lot of memory. Some of those references will be weak by the own infrastructure of Unreal. Some of them will be hard and just occupy more space and memory. So yeah, but you see that it's a pretty big blueprint here in terms of memory blueprints. So size, footprint actually, that's the name. So how can we decouple this kind of thing? Some strategies, of course, and which we'll be talking. And let me get back to the slides so we follow the logic there, but we'll get back here in a second. Okay, so when you do this kind of thing and you're just casting, you get very fragile class dependencies. Your blueprint graphs start being too tangled, hard to follow. And any changes that you do, they create requirements for you to fix and edit other systems which are basically unrelated. It makes things difficult to test, difficult to reuse, and hard to scale. How do references do compound fast? So instead of having those fixed connections, let's try to focus more in relationship by contract. What's a contract? It's basically a definition of interfaces. An interface is established set of types and variables, types for both functions and the variables, the parameters that you're using to communicate. Think of them like redirectors of data and functions, methods, right? Do not think of them like um, another source of naming conflicts. I know, when you're starting to play with interfaces, that usually comes to mind. It's like, well, so now I have a method and that's the name of the method, but then the interface has another name for that method and just matches by type. It is a bit confusing, but the important part is that, well, the identifier is not important. The signature is important. So what does that method takes? Does it take a data item? Does it return an integer for the amount of data items of that type? That's important. Okay, so the signature is important because that's what makes this connection, this glue thing that we call interfaces, actually work. So yeah, let's try to depend more on behavior. What does this function do? What does it return? Than the naming of the function. That's not important for interfaces. And doing that, you focus on explicit ownership boundaries, and to each its own, basically. That's also called loose coupling, where systems evolve independently. So basically, you're free to work on your character class, to work on your weapon system, and not be concerned if whatever you change in the weapon systems oh, now I changed a method name. Now I have to go back to the player class and update the call to the weapon system. I don't know, update weapon or update weapon model, whatever, right? So you become independent and obviously you end up with more reusability. And it tends to make, gameplay code much more readable. Um, I will add a parenthesis that sometimes it's a bit harder to follow because obviously if you have a hard reference, if you're on the IDE writer or Visual Studio, you can just control click something, you go there, right? And you go straight to the implementation of that piece of code. But the advantages vastly exceeds the disadvantages. As soon as you get a good structure in place, and I think in blueprints it's even easier, much easier than in C++ in terms of visibility, understanding what connects to what. And then you have a clear behavior boundary. So basically you have the caller, the implementer, which is, like I said, could be the weapon system, inventory system, whatever. And here would be your character class. And you have this um, in, intermediate, right, which just takes some calls and um, it has those calls implemented and has those variables implemented somewhere. And you guys are gonna see in practice how much easier it is than just having hard calls everywhere. So yeah, the main pattern is actually exactly what I mentioned about C++ interfaces. Um, Usually you start with the letter I when you define an interface, and you can define contracts. For instance, I'm gonna check if the door is interactable, and then chest can be interactable, and then NPC can be interactable. It's something that's really amazing for interfaces that you can have multiple interfaces implemented, which is a technical term for inheritance. Sorry, of interfaces. You don't say I inherited from interface A. You say I implemented interface A. And the cool thing is that even though C++ does support multiple class inheritance, in spite of many specialists' critics about this capability of C++ language of inheriting from multiple classes, which might lead to diamond and circular reference problems. The fact of the matter is that Unreal Engine does not support it, right? So it really doesn't matter for the task at hand. But interfaces, you can implement as many as one. So for instance, you could have at the same type the chest being I unlockable, I interactable, and I item provider or I inventory provider, because after you open the chest, it's going to give you a set of items, right? Which is amazing because all of those functions which will you have to implement in chest to provide an inventory set of items so that it's unlocked and etc. um, they will basically work with anything, like any item which interacts with item and has the possibility to interact with those interfaces. Okay. You avoid casting, and since you're not casting, you don't load all the memory of the chest in your character class or whatever is collecting opening this chest. And as such, it's ideal for object-to-object gameplay messaging. I want to stop and just give you guys some context here. There are two main types of object-to-object interaction or messaging. One of them is what I call static interaction or static messaging, which basically refers to actors or pawns or anything which exists in the world in the level, um, which pre-existed before you click play. Anything which is spawned during runtime, I call it dynamic actors. Some people call it runtime actors. It's the same thing. As long as you understand that those dynamic or runtime actors, they cannot be hard referenced because they didn't exist before the game run. And if you try to hard reference them in runtime, you will have some performance spikes because again, casting is not for free. I'm not saying never use it. C++ is pretty effective, and it's a good thing if you're doing it in C++. But if you do that in blueprints, it's sensible, right? So if you absolutely need to, I don't know how to do that. I need a cast. Um, please consider converting that to C++. I'm not good with C++. Really? I'll be honest with you guys. Take a screenshot of your blueprint function. Upload it to any LLM that you want, any of them, really, any, even Grok, which is terrible. It's gonna give you C++ code. It's that easy, really. There's no excuse, honestly, nowadays to not do C++. If you can do blueprints, and of course the game will not design itself, the game will not make high-level decisions. The LLMs are terrible for architecture. I really have a hard time understanding people praising LLMs for architecture. It's oh my God, it's usually so lame, and it's like plastered and bulky, and it's just not wise. It might be fast. It's definitely fast. It's pretty smart in some things, but it's a collection of Stack Overflow posts. It's basically a mishmash of ideas, and it's not even always the same. I wouldn't trust in that for architecture, honestly, but for spitting out code, and if you guide it, like, okay, that's what I want. That works in my game. I want it in C++. You know, it's your logic. Just use it, honestly. But anyways, it's very important that you avoid doing casting in runtime, for instance, during one interaction, one overlap of actors, or one contact, physical contact, if it's physical based game. Avoid doing casts there, right? That's really important. And that's when interfaces really shine. So let me show quick example of interface here. Let's see what we got for interfaces. I think I can do type interface. Nope. Then let me search for blueprints interfaces. Let me fix my keyboard. Just broke for a second. Let's switch it to the international language. All right. Okay, so we got some interfaces here. And I talk about HUD at the same time that I talk about interface. I think it's a pretty good example of how to use interfaces properly, right? Um, okay, so first let me show you guys the reference viewer and see how Belmont uh, use it, but you don't see the the output from it, right? Because whatever points to it has no hard link to it, and that's beautiful. Okay, so basically, this is just telling you that VP Belmont um, either implements or references this BPI. BP HUD either references or implements it because those are different things. And also, the player HUD, the widget blueprint, does it. Okay, so if I got this wrong, of course, I probably don't because I did it. But but just if I would open this project and I had never looked into it and I went straight to interface and I knew that designer was smart enough to use interface, I would instantly think, hey, whoever did this actually thought of updating the player HUD using this interface and using the HUD class because that's the icon for the base HUD class. So the base HUD class, it's actually it's not it's not obsolete in the sense of don't use it, but it's not the main way for you to create UI HUDs inside Unreal. So widget blueprints are, the best option for you to do it. But the widget blueprint is just the layout. So let me open that. And actually, I opened the asset itself. Otherwise, it won't let me show what goes. Um, widget blueprint. So you have inventory, item, and the actual player HUD. So here's the player HUD. It's fixed on screen, etc., etc. And I did a couple of tricks to be able to nest those things, but that's not the point at hand. But the thing is, this class has to live somewhere. You have to instance your UI onto something, okay? Um, and one of those possibilities is to do that using the character class. Yeah, you could, but is that appropriate? I don't think so. Uh, just because the HUD usually feeds information about the character, some information here wouldn't necessarily be about the local player, okay? If it's a single player more commonly, but suppose it's a multiplayer big match game arena style. Then you have, the scores for all players. The information which comes from those players is not yours, right? It's not from your local player. So why would you be mixing things? That's not a good usage of one of the main principles in game development, software development itself, which is separation of concerns. Keep whatever data is related to the player, keep it to the player. If it's not related to the player, don't keep it in the player. Simple enough, huh? But I've seen this done wrong so many times that I just have to stress it out. So what I do recommend really is that in your setup for the world where you have the game mode and the selected game mode, which is not being overridden here, right? So it's just using the defaults from project settings, but it's to create a HUD class just so you have an easy way to reference that anywhere. And basically that's what we do here. Let me just find where exactly. So just so you guys know, we have two graphs really, one just for input, just to keep things organized, where all the input actions are set here, and one for the main logic, like all the system events. And I tend to, as I improve the code, I tend to move things to the left in what I call a cemetery with code snippets. So in Begin Play, you see one thing that we're going to talk a bit more in detail, which is a subsystem. And this might be confusing when you use it the first time, which is, well, basically you want to use the enhanced input system. And then you face this node, what the heck is local player subsystem? Well, actually, there are two parts here. One is local player. I think everybody can understand that. It just refers to your own player. So when you're playing it, even if it's multiplayer, it'll just access the subsystem in the local machine. But the problem is, what's the subsystem, right? A subsystem, it's basically a singleton. It's basically a wrapper to a class which persists across the entire game. If memory doesn't fail me, and it might fail me, but that's something which runs on game state. It's like really low level. So it will persist even through different game modes. So yeah, it's probably there. And that's all it is. It's a singleton. It's data which is easily accessible everywhere. And you can create your own. So that's something that's pretty unique in your Unreal Engine. I don't think it's used enough. It should be used more often. And I'm going to show you guys a way to use it in a second. But actually what I did here was to get the player controller, and from there I get the HUD. Because the HUD, um, it basically depends on what player controller you're talking about. You can't just alt click and just have this guy. But the cool thing is that it's very simple, just two nodes, right? And even if you find that too much, you can just convert that to C++ class with a single get HUD from player zero. You could have that turned into just one node in Blueprints. That easy. Just seriously try it. It's really ridiculously easy. Take a screenshot, ask LLM. It's gonna give you just class. If you want it to be even more accurate, go to your IDE and just bridge that to whatever cheap signature you want, even some free LLMs, and it's gonna even use the package, everything. It's gonna just wire things up very easily. Again, I wouldn't recommend for structure, and I definitely wouldn't recommend it to try and set up your scene with it. No, don't do it. But for simple stuff like that, if it's bothering you and you're gonna reuse that, turn that into a single C++ node and be happy. Anyways, just two nodes. And more importantly, what would you do normally? You would say, well, I want from the HUD, I want to get the player HUD because that's the actual class. So I'd probably go and say cast to WBP if I don't even know if I can do that. I know I think I have um, to do get widgets something. I don't do it like that, so don't ask me really. But yeah, I think it's get widget or user widget, something like that, which basically will cast it into the specific widget type. You can check if the widget was added. You can, yeah, something like that. And then, well, as soon as you do that, you get a hard reference, okay? Because that'll be cast into the specific player HUD type. And what I did instead was in my um, actual HUD, let me get it, BP HUD. Uh, yeah, that's the one that I'd have to cast to here. Hold on, let me find that BP HUD, come here. Yeah, I think BP HUD. Yeah, that one. Okay. So, right. And then I cast it to BP HUD, and that's your, again, your knee-jerk reaction. Yeah, let me cast to BP HUD, and then I'll be able to get the specific, variables like whatever I need to set mana, whatever, and I just, get in here and just access that. But remember, from that, um, you would have something like functions to be able to set the mana percentage because you need it, right? On begin play, you just create that and you add it to viewport. That's just standard practice. And this will run automatically, so you don't have to worry too much. As long as it's assigned to your world settings, it's going to be executed and it's added. It's been shown automatically from just this simple set of nodes. Um, but you still would need to um, get the actual the widget, right? Because you're creating the widget from this class, and this guy is what actually has the values. Like, for instance, the mana percentage, it's progress bar. Yeah, you have that for health, and I have progress bar for mana, and then you have to actually tackle the percentage here, right? So it fills in or drains out. Okay, so that's the end goal. And obviously, if you go to graph, is where you create those variables, or at least you can manage those variables. So more commonly, you have those events, right? And then they can be implemented instead of being just regular events. They can be basically something that you created in your interface, which is, actually what's done here. So let me get the actual interface, show you guys. And you see, that's super simple. And interfaces, they're just a set of signatures and variable types with some name. You need a name. You need an identifier. You don't have to be super adamant about the name that you give it, but you need the name. It cannot be anonymous. So in this case, just to set the mana percentage, to set health percentage, of course, I would keep implementing things like, um, I don't know, probably set um, player level, set level, and that's simple. Just create it and what all the inputs? Just another level, new level. Could be add level, whatever you prefer. And then the type would be integer. And bang, you're done. Now you're able to, in your um, BP HUD, WPB, player HUD, everything which implements that interface now will gain this event. So you just go to class settings here at the top, and you make sure that BPI HUD, it's an implemented interface. And if it's not, you add it, just select here, filter for your, that's why prefixes are very useful really, and just implement whatever interface you created, right? So BPI HUD is added. So if it's added, I can search for instance, set level, and you see that I just got this added here. as soon as I compile the interface again. Now I have set level. This is not the event one. Let me find events normally at the top, event set level, that one. Okay. And it takes the new level variable. So if I want to just update the like it's in here, like with the set percent, then I have a function to set the level. Okay. And that's what actually is gonna update the variable here. So very simple. I can let me just make my designer level field, which is this one, text level. I'm just gonna make it public by clicking this variable or visible from graph. Then it pops up here. And let me compile it first so it shows up. And then I'm gonna have the variable name text level added here. Okay, and here as well. So I can just do set just by dragging with the Alt key held. Yeah, I'm gonna set it directly. I have to use the method call, so let me do it. Set. Actually, I have to get text level and set the label for it. Let me just get the right name so I don't do it wrong. That will be text. Yeah, label.text. Then I read that and do a set text. Set text. And the text will be the new level. So I just assign this in text parameter is going to convert that. And just make it a little bit prettier. Just like Ghostbusters, no cross lines. They're not good. They're going to blow up the world or something. Okay, so that's simple. And now I have this set. And how will I do that? I don't know, maybe here on BP Belmont, I just do the set level. Because, and why does that work? Let's think about that for a second. It works because it has an interface of that type. So basically what I'm telling you guys is that you don't need to cast. Casting will allow you to do it. Of course it will. You could just have something like set level, right? And ideally you will use the message one, not the parameter setting. So just select the messaging one. Yeah, does that work? It does. But now you're bringing in the entire memory footprint of BP HUD. Why? Not the best practice. Doing like that, basically I'm doing the same, but in a decoupled fashion because I'm using the set mana percent function of the interface. This guy here, this guy here, that case, right? And now I'll be using it set level from the interface, which is totally decoupled. I can just come in here and say, yeah, don't just set the mana percent. Also, let's do a set level. And of course, I don't have the item here. So yeah, let me just get the item first. Dragging from the source color is always easier, or else you have to scrub and scroll a lot and just takes too long. So just set level, use the message option, and bingo, done. That's simple. New level will be 1. So instead of the default text of 2, now it's going to set the text to 1. Okay, and I'm literally doing that on the fly. I didn't plan that, so if it doesn't work, don't curse me. But it might work. It should. So let's see. Let's see if I did everything that I did. BP bone, that's on begin play, and it's gonna get a minute percent and set level. And send 1, and then BP HUD will take it. And you have the set minute percent function, the target VPI HUD. And then the actual player HUD will take it. So let me see. It sets the player HUD. That's the target. That's the mana percentage. Yeah, I need a function event here too. Otherwise, it won't get to where it should be because there's actually a bypass. BP HUD receives it and then sends the message down to the instanced widget, the WBP player HUD. It's an instance widget. It's stored in this variable. So yeah, I just duplicate that, but let me add the event for set level. Let's see if that's the event one. No, it's not that. That one here is the event. And yeah, so I just pass it on directly, just like this one. Just do set level again. Just make sure it's the right one. Class set level. Okay. That's on the level, and the target will be player head. Just Control C, Control D, pointing to the position where you want it to spawn, and align. Select both. Hit Q to align it, make it look prettier, and you're done. I always use compile and save, so I don't. This one wasn't set, but so I don't have to click on both all the time. Compile, save, compile, save. Pretty tiresome. And I add the shortcut like Alt Q to compile. So usually when I'm lecturing or giving classes, I still click on the button because if I use a shortcut as I do in production time, people don't even know that I compiled it because you can see it from the asterisk here, but I do Alt Q so you guys can see what happens. Asterisk is gone, but it's such a tiny element that you probably won't see it. And if I'm talking, I might just forget to mention that I have compiled it. Okay, so same thing here. Let me just make sure that Belmont has it. Okay, set level, compile, and save, compile and save. Yeah, let's see how that goes. Hit play. Yeah, I didn't see the update here, so there's probably something missing there. Yeah, that's the flow, even though we can just add a couple debug points to see if it got to the LVP player HUD. Like for instance, here. Oh, I didn't connect the flow. That's a serious problem. So let's see if that works. Okay, stop, file, and run. All right, level one worked perfectly. Okay. Very simple. And now it's fully decoupled. So that's the gist of it. That's the basic logic. Doesn't take too much time, really. Just define your interfaces um, and assign the functions. There's some wiring, extra wiring to do because I'm basically using the HUD as an easy way to get access to to the HUD, to the player HUD, without using um, a subsystem for that because there's already a subsystem. When you get HUD, you're basically kind of accessing a subsystem. It's not the very same because this actually predates the HUD class reference, global reference predates subsystems. So that's why it looks a bit more simple, like just get player controller, get HUD. It's because it's lower level but the functionality is the same. When you do get player controller, get HUD, those are globally available functions, which will just return to you whatever class, again, is defined either here or in the in project settings if you're using the defaults for maps and modes. Right? Let me click here. It's just super slow, but yeah. Come on. I should have stopped the game. Okay, now it works. So yeah, so just define the class here. For you to create a class like that, literally just create a blueprint, select HUD, done. That easy, okay? All right, so that's the basic workflow for interfaces. Let's keep going. Uh-huh. All right, and now we get to C++ subsystems. Oh, let me check for you guys' comments. Usually I read them at the end, but let me do it now as I have some water. I've heard about Halil said, I've heard about one of the practice for controller widgets is through the player controller. That's true. That's true. And to access widget data through the game mode or state. Wait. Um, control widgets through the player controller. That's very similar to what I mentioned about, having unrelated to the character data in the character, right? You can do that. It's not forbidden. And as I always tell my students, players will not play your code. They will play your game, right? So it's not like, oh my God, someone's gonna shoot you because oh my God, you just kept all your HUD information, HUD specific data, even widgets in the character class. That's terrible. That's not true. It's not terrible. I just think it creates work for yourself. And especially for a future self, because as you learn more and more, you tend to rely more on this kind of reliable pattern where you get obsessive about not having unrelated data in certain objects, which is what we call separation of concerns, right? So yeah, it's not a crime. You won't go to jail because of that, but I wouldn't do that personally. And to access widget data through the game mode or state. Through the game mode, yes, it's a good approach. I did that for the tanks game, just because I felt, all the HUD concepts were a bit too complicated for the first project that we dealt with in the GDP course. So, but yeah, you can do it. And I think game mode is a pretty good place. Um, I still think HUD it's a better place, but only if you're ready to use interfaces. If you still don't feel comfortable using interfaces, even after what I've shown here, um, basically proving that it's not hard and it's something that you can just play around and get working, well, then yeah, probably game mode would be second best. What's the best hierarchy for communicating with widgets? What I just shown, in my opinion, of course. Um, we have to create the widgets better to cast or create the widget. You cannot cast to the widget when you're instancing it. Casting is a conversion. You need a pre-existing object first. All right. If it doesn't exist, you cannot cast. You can't cast something out of nothing. It's basically would be materializing out of thin air, right? So yeah, that's in that case not an option. All right. Let's go then. So subsystems. There are many. Game instance subsystem, world subsystem, local player subsystem. And you can inherit from them, which is pretty cool. So game instance subsystems are really the most powerful ones because they're very low level, like I said. Um, but you also have old subsystems which are related to the level, which is in memory at that moment. Local player, as the name states, is for things related for uh, whoever's playing this um, instance. I don't know how to say that better. So imagine a multiplayer game, um, and there are, I don't know, 8, 10, 64, 100 players simultaneously in the same level, in the same space. Um, Local player system is basically your machine. It refers to the byte code which is being executed in your specific processor. Okay. So, what's it good for? Pretty much any set of data which, or even functionality, although there are better ways to do functionality. Usually, you do that for data. Any set of data which has to be used from multiple parts of your game, from multiple parts of your game. So it's good for matchmaking, for saves, for inventory, which is the example that I'm going to be showing you guys. Analytics, when you want to know, just gather information about how far into a level your player went, um, to know how hard the game is, and after it's live, this kind of information, which we call analytics. Audio routing, when you want, basically a subsystem with where you have multiple um, objects or even functions. You could do it for functions there as well, no problem. Where you can just do things like, play next screen or something like that, and it just picks the next screen sound or the least used screen sound from a set of zombie sounds, and then it adjusts the pitch and plays that, right? So that could be a function in your subsystem. It totally gets rid of the manager actor sprawl, which is getting the player controller or getting the player character and then casting into the specific class, which again is not terrible when it's a static object. So um, I don't know. Let's think. For instance, suppose you have a trap, right? A trap is defined in the map. It pre-exists. It exists in the game in the level before you hit play. So it's a static actor. Okay. And so what do I do? Basically, I can go to begin play and I can say, um, I want a reference to the player character. So I can just get player character 0 and I cast it into my specific class, BP Belmont in this game, specific game's case, and I cache it because if I cache it, I want cast it again because I already have a reference to it. Does that work? Yeah. Is that a problem? Not really, because this will be executed in the very first frame of the game. The problem is when you're doing things after the first frame of the game, because that might result in bad peaks of performance, right? The performance drops, frame drops, loss of FPS. You don't want that, right? So feel free to cast and cache whenever you're doing things on first frame. And for you to be sure that it's in the first frame, it has to be a static actor. If it's something that you're going to spawn later, sorry, man, not a good idea. Do it in another way. Maybe using a subsystem. It's a great way to do to get a reference to the player character, right? And all its data. So again, for a trap which exists in the level, you can just do a cast on begin play and you store it in a variable, which is called caching. And whatever you need to do later, you even on tick if required, try to avoid it, but if needed, you can just use the reference to the character to check for if it was the character which collided or triggered it somehow, the specific trap. But imagine it's a boss which lays traps on the ground, maybe invisible traps, whatever, and you need a detector. Those traps will be instants, right? They didn't exist before the game ran, and it won't exist until you actually meet the boss. And now you want to check if the player collided or overlapped that shape, that collision shape. Um, you don't want casting, okay? You might do it with interfaces, pretty simply, but definitely don't try to do it with casting. That's a bad approach. So yeah, and you keep the service access intentional and discoverable. Yeah, because it's basically accessible anywhere. How does that work? Okay, let's go to practical example. Subsystems are not hard to implement. They're actually pretty simple. What I did, because it takes a little bit of code to make a valid example. So what I did was before the class, I quickly created um, a couple of classes to exemplify good usability. Let me move this over there. So basically, this is already a C++ project, which basically means you can use C++ and Blueprint, right? When you say, oh, it's a C++ Unreal Engine project, some people instantly think that there's no Blueprint code whatsoever. That's a massive lie. Even the best game projects will use some parts of it in pure blueprints because it's the best way for you to manage assets, animations, sounds, right? And to do that from code, it's both not recommendable and super slow actually because it's not tailored to do that. If you want to do everything on C++, don't use the game engine. Seriously, I'm not even kidding. I'm just laughing because people don't seem to realize that. Anyways, so what I did was I created data asset item, which inherits from data asset as a parent class. You can see that here. Okay. And I created inventory subsystem, which inherited, because I already created from game instance subsystem. And like I said, there are many subsystems, and when you create a new C++ class, you go to all classes and you select subsystem. You see there are all those many different types. Editor subsystem, which you use in custom editors, right? So many, many, many of them. But the game instance subsystem is a very powerful one, and you can just search for that directly if you want. Game instance subsystem, it's here, right? So that's what I did. Just created from there and with the right naming. And usually it's the recommended approach because there's some code which is generated by Unreal as helpers to your actual classes. So it's recommended workflow is to always create the classes that you need within the public folder. Then you go back to Writer and make sure to run your project from Writer as well, if it's a C++ project. So if you clone some Unreal Engine project from a GitHub and it tells you that it's a C++ project, instead of opening it straight from Unreal Engine, open it from within Visual Studio or Writer and build it, right? Build it the first time and then you run it. So that you get a perfect connection bridge between both. Okay, so like I said, it builds some things like this generated body and it templates some things like some includes are done for you automatically. All includes have to go before the auto-generated code for the name of the class, which is usually the last line here. Make sure it keeps being the last one, even if you have to add 10 or more includes, doesn't matter, just pile them up before that. This is just generic C++ for Unreal Engine. And yeah, that's what it inherits from. And the actual name that you gave within the Unreal Engine editor, it gets an added U, which is just a naming convention for Unreal Engine classes. All right, so if it's not very easy to read this, I recommend you guys, I use this trick of offsetting, the function, because those are basically decorators. They just um, add some extra functionality through macros in C++. But what actually matters is that you can read the functions, what do they return, right? And yeah, what do they take as parameters? All of them take one item as a parameter, and then you can set the item count for that item. So the actual data is a T map. A map is a dictionary in C++, which takes object pointer of items as a key. That's why I have those nested angled brackets and return a number. So it's as simple as I have an item type like a health potion, and I want to know how many health potions I'm carrying. I have, I don't know, a ring of power, a stamina boost item, whatever, which you can even easily tie to the gas system. I want to know how many of them I hold. It's that simple. Um, I do recommend that if you want to add functionality to the items in your inventory system for when they're collected or something, you use a different approach. Inventories, they should be as simple as possible. Try not to make it too fancy, right? They're storage of what you have and how many of each item you have. That's what they should be. So you could use other maps or even maps from struct data, identifiers to struct data, right? So there are other ways. So if you check, for instance, item itself, it's just got, let me offset that a little bit. Let's copy that so it's easier to read again. So we just have item ID, display name, and the texture TD using a pointer because you don't want to copy the content of texture. You just want a pointer to it. And that's a native pointer type for Unreal Engine. It's just a facility, and you should use it so that Unreal manages the memory and prevents C++ from exploding your computer or doing something worse. But basically, yeah, that's what you have. Just an F name for um, nothing. This instance with nothing. That's just a macro with a zeroed out or empty value, meaning no name, and the display name, which should be shown for UI purposes. Can you add more things here? Yeah, you could have description. You could have other things. I'm just not a big fan of adding functionality here. Although you could have kind of struct with parameters, item parameters, and then you just have a reference to that struct for specific item parameters. And those item parameters could even include gas abilities for when it's collected. Hmm. That would be interesting because then you would be decoupling the actual fact of supposing it's instantly activatable item, right? Something like because potions many times you get the potion but you don't consume them immediately. So you have those auto activated items and the collectible items which are not auto activated. And of course, here doesn't make sense because that's inventory, so you're supposed to be collecting things for later users, right? But anyways, you see that's it's very simple. You don't even have code, implementation code. It's just data, right? And why they do that? Because they want the designer to easily be able to customize that. And inventory, because it's dynamic, will just hold this dictionary and have functions to check, for instance, if there's a certain item, any item type, which is basically, knowing if this is not zero. That simple. Look at the code, it's ridiculous. Add item count. Supposing it's not valid, set item count, the current item count amount plus the delta that we're adding. Oh, remove item. Remove item. It's pretty ridiculous. Oh, do I have an item? If the item count is greater than zero, I have the item. Wow, genius. Okay, so pretty simple. And just a simple get inventory items, which is just generic blueprint enableable, how to call that? Yeah, blueprint read-only function, which allows you to get the entire map, right? So how do you use that? It's this is a subsystem, and that's all I have to do. Yeah, that's all you have to do. Just make sure it inherits from your game instance subsystem. You add some functions to it. You make sure that you have the required data, and that's all you need. Just like magic. And I'm not kidding. You don't even have to instance um, to make an instance of that. It's literally done. I know it's kind of hard to understand, but yeah, that's the magic of Unreal and subsystems. They just exist. You cannot do those in blueprints by default. I know there are a couple assets um, on Fab which give you this kind of functionality, but they're basically code generators, right? And honestly, don't spend your money. Come on, you can just create those in just a couple clicks. Just oh, I don't know anything about C++. I won't repeat myself. Use your LLM and get rid of this pain. Anyways, what you do is, let's go here for instance, BP Belmont. Let's make so that when I touch an item, I won't make the full implementation, but I just want to show you guys how we do the basic. So yeah, this was an older version of a simpler inventory system that I worked um, with the GDP cohort. I think GDP 12. I don't remember, maybe 12 or 13. Cole is here; he might get me corrected. But yeah, I basically did everything using blueprints. I didn't use subsystem, no C++ class, etc., etc., just to show the logic, of course. But again, I didn't implement interfaces, so I did a cast. That's no good. That's the type of approach that you shouldn't do. So of course I would update that and move it to my good old cemetery as something that you should have just, I don't know, for a quick prototype or something, but yeah, don't do that. So let me just yeah, I can't duplicate it like that. So let me just, I don't want to unwire. So I'm going to do something ugly here. But basically on component begin overlap, I will get the inventory subsystem. Okay, so let me just follow the steps. First, let's get something so we can consume because right now we don't have nothing to consume, which are the data types. So let's go to data, not blueprints data, just data. And let me add um, from miscellaneous. Yeah, it's not a blueprint class, right? So what we want is the data asset from our DA item class, but you don't inherit from blueprint class. You have to literally go to miscellaneous and find data asset. And then you find data item, okay? It's a data asset instance. That's why I usually name those instances as DAI something. So the I, this would be the health potion. And let's open it. Pretty simple, it's just data. I even minimize it because I don't need it to be that wide. And all I have is an item ID, something like, I don't know, maybe item one. Display name will be health potion. Guess what? And luckily I have one icon for health potion here, which I created previously. So health potion icon, done, bang, good to go. Now let me get myself another data asset item, and I call it mana potion. I just duplicated it because it's just easier, right? I just remove the one at the end. That was the leftover from duplication. And yeah, mana potion. And of course, oops, double spaces. And just select mana and good to go. There, bingo. Okay, so now we got, and of course you would organize things like, I don't know, maybe collectible items, collectible data items. Now let me move my potions in there, here, and cool. And I see that how easy it is for designers to just duplicate and edit things and just, change their icons. And like I said, if you want some data being added there, just create a simple structure reference. You create a structure with multiple properties to be used there. And you can even use there are a couple of layout options. So you can check for sorting. There's this, what is that? I think it's column. Yeah, I can check for column. You can check like a list. So it starts to look a bit more like a spreadsheet of sorts. So yeah, feel free to play with viewing options. You can change thumbnail size, etc. There are many ways for you to do with that. And now let's get back here. What I want, I'm sure I have it compiled. What I want is to get the inventory subsystem. Get inventory subsystem. Yay, here it is. Check how cool is the icon is red, because that basically means it comes from the C++ world and not from the Blueprint world. Okay, so yeah, here it goes. Our brand new inventory subsystem. And what I want is you cannot break it. You have to like call the functions. Let me see, something like, yeah, I don't even remember the names that I gave you. It should be at the bottom, or I can also look at the code, of course. Yeah, I should have given it a better name. It's just get item count and um, get inventory items. That's the one. Okay, so get inventory items. Nah, not that. Inventory items or get item counts. That's basically the table, right? And then you can, as you can see, it's a map. It's like a dictionary, so you can go through that if you want, like for each loop from the map. Then you can check the keys and values. You can do whatever you want on the entire table, or you can just, for instance, um, add an item. And let's see, I have item count and the item. Suppose I have noticed that I just touched um, a health potion. You can do that in a couple of ways, right? One of those would be checking for the identifier. You could and probably should, from data asset, have an interface. And I won't implement it now. It would take a little bit of time, which we don't have. But basically, you have a new interface for data items where you have the get type or ID. Type is probably better. But anyways, you would check for something, be it the name, the item ID, whatever, which could be another reference to. And then if it's the type they want, or you can just, because you have the actual element, right, from the potion. Because remember, okay, let me take a step back to make this clear. When you add an item count, what you do is you select the item. So if I know what's the data item and which I would get from the interface. So basically from the interface, I would get the data item, right? Um, which comes from the other actor. So if I got the item, which will be from the right type data asset for items, I can just wire that into item. Okay. So obviously I'm doing that just manually. I'm just adding two, sorry, adding just one, but that's how you would do it more properly. So what I'm doing here is just as soon as I overlap whatever, because I'm not checking for the type, I will add to the AI health potion one. Okay. And I would filter the type using that. You can also get the check it for gameplay tags, which do not require casting itself. You can do that from regular tags. Suppose you want to go that path. I do recommend using gameplay tags, they're much better. But you see that this is done. And if I want to show the inventory in my inventory screen, let me find that really quickly to show you guys. I'll do the inventory. So, it's just a list, and I can just get the icon, get the description, which I don't have there, could be just the item name, and times the amount. I would just fill in those fields from my graph, basically by taking the functions from an event. And I would, again, um, add an interface. It could be just inventory interface or inventory widget, I inventory widget. Doesn't matter. As long as you have the right events connected, I would just be able to send this information to inventory straight from the collection moment, right? And I would just receive that information very easily. I could do that from the HUD. The HUD would then, not just spawn the player HUD, the regular player HUD, but also the inventory menu, and it would hide it. So basically, you could just instant it and not add to viewport or add it to viewport and hide it. That's up to you. And when you want to show the inventory, you could hide the HUD or leave the HUD, up to you again, or design specs, very easily, right? So you can notice that when you use this kind of approach, things start getting much more modular and start getting much more sane for it to work. Then imagine if you're trying to check for the type one by one, and the more item types you have, the more complicated it would get. But doing it like that, it's just a matter of duplicating the item and automatically from the collection here, from the collection logic, you would just get from the interface the item type, feed that into item, connect inventory subsystem, and bang, you're done. You could even have something like, because this has to be redrawn here in Designer, it has to be redrawn, for all the shown elements anyways. You could just have a message sent to it just saying update from inventory. And then your blueprint would just do a loop going through the elements just like we did here. Why? Because here in graph, I can also get the inventory subsystem. Like so. It's literally available everywhere in your project, and you're always accessing the same data. So it's really amazing if you ask. I really love it. All right, so let's get back to our slides. We're gonna have like some more 15 minutes, then I open up to questions, right? So yeah, let's go to delegates and event dispatchers. Delegates and event dispatchers use events instead of polling or direct calls. Polling is basically, shirks Tracks donkey style. Are we there yet? Are we there yet? Are we there yet? Like every tick, you check for a value elsewhere. Terrible approach. The best, the best approach is always to have when one state was changed in the game. What state? Maybe you collided with something. Maybe your health is low and you want to have your UI blinking for that's kind of to send a feedback to your player, right? That's when you have this event which communicates to multiple systems. Those guys could be subsystems. You could have the Quest subsystem, the audio subsystem, the UI subsystem, or you could have specific actors or parts of your system which takes this kind of message. But the important part is that you'll be using messages. And messages, they when you're using the delegate pattern, it's basically one guy hosts is like the the dispatcher of the message. That's why in Blueprints, well, it's called event dispatcher and not delegate. In C++, the right term is delegate. It's basically a pointer of sorts, but which can hold multiple addresses instead of just one. So a good example that I always like to give is imagine you have um, a bullet hell, like a spaceship, enemy ships coming, typical 90s bullet hell game. And you have this this big bomb um, power up or item. As soon as you touch the big bomb, all the NPC ships will blow up instantly. But which spaceships are our enemy spaceships are those? Well, the NPC spaceships which are on screen. You won't do it for the spaceships which are off screen or which just left or which weren't spawned yet. So how can you do that? One of the ways you can do it is you can, once you select the power up or touch the power up, you go through all actors on the scene and then you check for their type, or maybe you already have an array of spawned NPC ships, and then you go through the array and you just say, yeah, destroy yourself, destroy yourself, destroy yourself. Okay, that's one way. But it's obviously a pretty slow way because it requires you to go through a list. And if you have hundreds of elements, which sometimes it's the case for bullet hell style games, and obviously bigger games like MMOs and stuff, it's a pretty slow process to go through that list. Instead, you can just use delegates, which are, like I said, a variable holding method calls pointers to methods in other entities, in other actors, in other objects, so that you can basically fire remotely those methods elsewhere from a single method call. So when you run a delegate, when you execute a delegate, or when you run one event dispatcher, you're basically dispatching the message to all subscribers in all those systems, be those the NPC ships example that I gave, or to the subsystems that are taking those messages, and you do that with a single call, which is immensely more effective and prevents spikes in your game. So it's really performance optimal to do that. And you have the blueprints event dispatchers, which is totally designer friendly, great for UI updates, gameplay reactions, date changes, all of those. So just to quickly show the event dispatchers, like for example, let's see. I think I have a couple here in my main class because I used it a bit. The game mode. It's just yeah, I think that's the one we're using. No, I think this one I didn't get to add an event dispatcher, but yeah, it could be here, right? So this is the game mode. You see that um, it's where many times I store important variables, not for the specific game, but I could have something like, let's call it player die, player die. Okay. Well, um, That's an important event. Many things will happen when the player has died. The UI might either fade out or disappear totally. Maybe the camera is going to navigate and give you that dramatic kill shot. Camera just rotating around that you can better see all the blood and gore because players are like that. What can we do? But anyways, it's something that will affect multiple systems. For instance, the input system will be disabled. You won't be able to move your own dead body. Well, I hope not. That would be kind of ghostly. Depends on the game style. But anyways, you probably wouldn't, and you no longer be a target. NPC, all the NPCs in the game should start ignoring you. Well, maybe if they're like like buzzards or something, they could still go and try to feast on your flesh. Well, this is getting gory. Anyways, I'm just saying many systems, many actors will have to be alerted out of by this event, that this thing happened. It's a very important thing. So you just add it. It's really that simple. Make sure to compile it, and you can, add parameters if you want, add inputs, but more commonly than not, it's just a multicast delegate, which means multiple actors will be able to trigger it, and you can subscribe to it. Okay, so from this guy, and by the way, you can get the game mode pretty easily. Like I think I did that on begin play. Not really, but I could. It's just a get game mode, and then you have to cast into the specific one, cast to VP view red game mode. Okay, and now you would cache this instantly before you forget. And again, I can do that shamelessly because it's on begin play, so absolutely no problem. I just have to make sure I do this right. Pop this over there. There you go. So now I have that game mode reference. Let me just rename it. There you go. Okay, so now I have a reference to the game mode, and anytime that I need that, um, I need to call um, this player died, for instance. I could do it very easily just by getting the game mode ref, player died, call player died. And for the subscribers in my bullet hell example, those would be the NPC ships, maybe the NPC ship projectiles too, which would just, disappear because their parents or you know uh, ignition or originators were also destroyed. You would bind a certain event, okay, and this event will basically be the function which will be like destroy myself, okay, on each of the NPC ships, so that when I fire, explode all ships on screen or explode those ships, all enemy ships, it will just fire all the methods assigned to it. But from whatever triggers the event, it'll be called clear die. This would probably be assigned to, the event when you collect, etc. So that's on the caller. And for the receivers, you would do binding, more commonly on begin play. And bind is, pretty lightweight. It's not something that's as expensive as casting. So that's the entire workflow for you to use delegates. Pretty simple. All right. Yeah, that's it. So how do I choose the right pattern? You see that I've used, you know, pretty much all of those during those 1 hour and a half. So how do I choose the right approach, the right pattern for each decision? let's start from bottom up. So I do direct reference, which means casting and storing a cache to it when, especially when it's a static object, right? Which basically allows you to have this stable ownership, which predates or pre-exists the game execution. If you need, the question is, who will react to this event? If that's the kind of question that you're thinking about, you will be using a delegate or event dispatcher. Okay, delegate in C++ and event dispatcher in the blueprints world. So it's like, yeah, one event which will affect many entities or many components in the same entity, like I said. That's a typical use case for delegates. Use subsystems for easy access to services. I think to think about services. Think about you know big features of your game. Things like world map. You can have don't think about world map as the actual level map. World map as like a navigation map, like the ones you get in Zelda and other big maze or open world style games. And then you would have the world map subsystem. Anytime that you want to do something or check something, if it's been shown, or you want to add a ping to that element, you will do it. And the subsystem could then alert the HUD widget blueprint to update itself from its data. And you do interface when the question is, can object do this or that? If it does, do it. There's a node which is pretty handy for that. I forgot to show it. It's let me just delete you and add tag added, perception data, yeah, player controller. Where's trigger um overlap here. So you see, this is just a generic actor reference, but you can do something like this implement interface. So does that object implement interface, for instance, I interactable? I don't think I have added it, but anyways, I should have added it. Let me get another interface. I interactable, that should be around here. Um, interface actor sub object. Yeah, let me just get one from the project itself. It'll be easier. Blueprints, interfaces. Um, yeah, let me just get the BPI inventory. I would probably have an interface for um, data item, like I mentioned to you guys, but I just want to showcase the point. BPI inventory. I don't know, something. BPI NPC, yeah, that's better. So basically, if this object implements um, the BPI NPC interface, I know that I can just call any parameters from that interface, be those functions or variables. So just get just check what did I add there. I have set cursor visibility, which is just to show or hide the element below it and just show it. So basically, I can just rotate around and using the mouse, and when I hold the right mouse button, I get this cursor. And as soon as I, get track of it, then I can fire the ability, etc. To slow down the servant zombie like. And you see that cursor being shown? It's basically something that I enable or hide using interfaces. That's why I created this guy. So that's what the set cursor visibility does in a totally decoupled fashion. So, I could do this kind of test and do something like, check and check if it's true. If it's true, then I'm gonna do the set cursor visibility, for instance, messaging, and I make that true or false or whatever. And yeah, you can do like that, but honestly, you don't need to. Because what happens is, supposing this other actor does not implement the interface, it will just fail silently. It won't give you an error. So if you want to debug that, okay, then probably you could use the branch that you have something where you can just hit F9 and toggle on the breakpoint. But more often than not, what you will just want is to pass on the actor as a target and send that message. And yeah, if the target object doesn't implement the BPI NPC interface, it'll just not do anything, right? It won't give you an error. It just won't work. But yeah, you're just assuming that if possible, set cursor visibility. If not, just move on. Nothing to see here. Okay. So that's a pretty common use case. But if you want to check for type um, and not cast, or only cast if you're absolutely sure that the type is the type that you want. One of the options is doing does implement interface, right? It won't return you a concrete implementation, but um, if if you absolutely need the cast and more commonly you don't, you can just set everything through the interface. But I don't know, maybe you need to check for type before doing something because of the UI. Then you can do like that. Okay. Um, yeah, so I think those are the questions and those are the answers going from bottom to top, the four main options that I recommend to use. Brett said he likes to use messaging system for the HUD. Event listeners can filter what they want to access, and it's not needed as consumed in the same frame. That's true. It's totally, totally better to just send messages when it's really required. So yeah, totally agree. So, one possibility that you can use is to define your interfaces in C++. All right, and the content should be in Blueprint. The gameplay tags um, are pretty hard to make work pure blueprints. I already got a couple extra gray hairs just from struggling with that. And now I prefer just doing gameplay tags exclusively on the game the game ability system, the gas system, which is built in. It's a default option in Unreal Engine. So yeah, it's got a little bit of an extra setup, but once it's done, it's really easy for you to work with those gameplay tags. And then you have the data assets for designer friendly work. So basically that's the designer part and that's the programming only part. Okay. There are a couple of problems with interfaces in using them in blueprints, like they will be visible, but checking for types um, is not something you will be able to do in your own functions. Like you can't check if it does implement, okay? But if you try to do that in your own blueprint functions, there's no interface type, right? There is an interface type in C++, but there's no interface type in blueprints. So you might run into a couple blockers. Um, I honestly, I prefer having my interfaces set in blueprints. It's been more flexible for me. And then you compose behavior and content, gameplay tags and data assets, reduce hardcode branching. Modular features and plugins isolate systems, true. And code reviews enforce dependency direction. Yeah, that's true. You also have to make sure that the data and the dependency is flowing towards the right direction. If the biggest consumer of your game is the HUD, make sure that it's the end consumer of every information and not that it takes some information, then it passes on to whatever else, and then it updates I don't know, maybe the saved game state, you know. Just make sure that whatever you have to do, you do it before you show the data. I think that's an important hint. All right, final takeaways. Casting is not an architecture feature. It's a tool that you must know how to use and when to use. Interfaces are awesome, just awesome. They reduce class coupling a lot. And by the way, interfaces, they can not just send value, they can also get value, right? So I have at least one that I did. Let's see if I can find it here. Mhm. Different interfaces. Let's see. Yeah, I think I did one for the first my first implementation for inventory. And you have this get amount. And you see that it takes the item type and outputs the amount. Okay. So just feed it like that. And you have to wire it like so. And the actual implementation also, let's see if I did or if I have deleted it. That's BP HUD. Class settings. Just I'm just checking if I did implement the thing. Yeah, BPI HUD. Mm, yeah, but BPI HUD just has set ones. Well, when you have get ones, actually in the actual implementation, you need to add a function. It will not become an event, right? That's the only difference. You will just add it as a regular function because you have to return something and it'll be wrapped into a function. That's the only main difference there. The rest is basically the same. Um, yeah, interfaces, subsystems facilitate access. Definitely it makes it very easy for you to access the same source of code. Delegates enable reactive systems. Yes, of course. Your systems start being aware of what's going on without having to constantly pull the supposed game manager or even the player character or the level blueprint. And yeah, so scalable real code always requires proper design for it, always require you to define your communication boundaries. What talks to what, in which form, and the frequency. And the final architecture is just a result of this definition of boundaries of when we use interfaces, when you use subsystems, when we use classes or delegates, right? Um, I'm gonna check the comments here. Feel free to add more questions. I'll be reading as many as I can if you have some time. All right, so let me move up a little bit. Brett said he likes to use messaging system for the HUD. And listen, yeah, so there's something called the Lyra messaging system. I should have added a slide for it. Let me find it real quick. I know it has been decoupled from Lyra. Yeah, this one. Gameplay message router. I'm just gonna drop the link here if you guys want to check later. Where's the chat? Here. Okay. Gameplay message router. So that's basically it was an extraction from the Lighter project. You can get it from Lighter GitHub repo. But yeah, it gives you basically you set up a message, very simple, just set the structure and a function to send the message. You make it blueprint callable, so it becomes a node. You add this U function and blueprint callable tag. And you define the channel. What's the channel? It's basically so that you can filter so that you don't have a global channel for all messages. You might have, um, and you see that creates a subsystem for you. So you might have, and by the way, that's simply by adding the plugin, right? You just add the plugin that sets up this master subsystem for you. And then you just make a text, which, just takes whatever. integer boolean, and then you define the channel. So the channel could be, for instance, I want to use the weapon channel for some communication to check if the enemy has a certain weapon. My character will be more scared, or this other character will be scared of that other character. So you can use the communication channel like that by filtering messages, and it just makes things easier. So see that it's got a couple examples there. It's very simple. Just send message, and yeah, you make the struct that you created here, um, like that. Okay. Let's see. Yeah, just check out the example. It's very simple to use. It's a global messaging system, but which can also filter for channels, like I said. Okay, so there are some nice examples here. Um, okay, back to the messages. Event listeners can filter what they want to access, and it's not needed that it's consumed in the same frame. Yeah. So event listeners, after you take one event, you can also add your own filters. Definitely, if something is blocked or you receive an open door message, right? And it's still locked, it won't work. So you can add as much logic as you want after the message received. You're not forced to react upon it totally, let's call it like that. What else? So it's better to make C++ blueprints instead of strictly blueprints. Yeah, totally. A prototype blueprints, that's what Brad said. Then convert C++ if I like how it works. Totally. Yeah, that's something I do very often. There's some there's some connections between nodes, those wires, which just starts becoming cumbersome, really, to use. Um, Mathematical functions, definitely move them to blueprints, to C++. You can even test them in blueprints. It's pretty painful. Like, if you want an addition, you get one variable, you get the other variable, and then you get the node for addition. And if you have like parentheses, and then you start creating hierarchy, and then you want to multiply by whatever, you know, then divide. It's pretty tiresome to do math in nodes, in blueprint nodes. And doing those and C++ is ridiculously easier and faster. If you're doing long loops, so in that case, for instance, the inventory, if it's small, all good. But if you have a long possible list of inventory items like Zelda, have like tens or even hundreds of different items, no good to go through a long list and just fetching variables from that, convert that to C++. Aim said, how does that work? I'm creating games solely in blueprints. Yeah, basically you take it. You can do it by hand, nothing stops you. But if you want to learn, one of the best ways is just ask your LLM to convert it. You may use Gemini is incredibly good, and even on free account, you can convert a pretty good number of blueprints every day into blueprints in C++ code very easily. And of course, it's good for you to know a couple things. Like it probably will give you some generic code, like it'll ask you to, on the headers, to replace this part, actually not this one, to replace this part with your actual class name. So the first thing you would do is go to, is converting your project to, hold on, to C++, which is literally just a matter of coming here at the top and creating a new C++ class. So before you do that, it's still a pure blueprints project. As soon as you do that, it'll take some time because it's gonna bring in the whole source code. It'll create this folder here at the bottom, the C++ classes folder and the project subfolder and public, etc., etc. So, and here's where you're gonna add your C++ classes. Once you do that, you will add it. I recommend Writer. It's the best code completion / IntelliSense. It's got perfect integration with Codex, the GPT coding platform, Gemini, even the rich people's platform, Anthropics. Yeah, you can use Cloud Code there as well. Um, what else? There are many new LLMs which are free. You can run even in your own computer, but I don't recommend doing it if you don't have a really bulky GPU. But if you worry about, sending data to weird places in the internet, you can just opt for that. Um, yeah, do however you prefer. Doing it integrated in the editor will give you less chance for errors. It's gonna be able to help you when you have an error, like you can just paste, oh, I got this error, please help me fix it. That's simple. Usually it's a great way to learn because C++ can be daunting, and we now have this great tool to learn and to help us um, build our dream games in a much better way, in a much more optimized fashion. So not using it would be a waste. Um, what else? Yeah, I talked about Gameplay Master Router. Brad said he thinks he used that one. Georgia, thanks for class. Thank you, Georgia. And remember, more than one receiver can receive the same master totally. Yeah, you can just subscribe to the message, which usually will be you can store that in multiple places, right? You can store that on the game mode, like I did in this example. You can store that in the character, many places really depends on what you want to do, right? If you're going to destroy the character at some moment, better not have event dispatchers or delegates there, right? But if it's something permanent, God forbid, you can do that on the um, on the level blueprint too. Okay. Anyways, many ways to do that. All right, guys, we're at the end of our time. I'd like to thank you very much for you participating in this presentation. Yeah, I had lots of fun setting it up, and I'll be around if you need me. Here's my contact, and yeah, thank you so much for your time. Reach out anytime, and I'll be more than glad to help. Talk to you later. Cheers. Bye bye. Thank you.